the cabling should not be non-plenum rated. National Electrical Code (NEC) Article 300.22c3 states that conductors installed above suspended ceilings in accordance with 300.22c2 shall be Type MC cable, Type 2C cable, mineral insulated metal sheath cable, Type AC cable, Type MI cable, Type ITC non-metallic sheath cable, or other approved cables. All cables shall be listed as having adequate fire-resistant characteristics. NFPA 90. A standard for the installation of air conditioning and ventilating systems defines a plenum as a compartment or chamber to which one or more air ducts are connected and that forms part of the air distribution system. While the upper ceiling space is not technically a return air plenum, it is still an air handling space that could potentially contain smoke and combustion products in the event of a fire. Therefore, the cabling installed in this space must meet the same fire-resistant requirements as if it were in a plenum. Using non-plenum rated cabling in an air handling space can be dangerous because it could spread fire. Non-plenum rated cables are not designed to withstand the high temperatures and flames of a fire and can melt or burn, releasing toxic gases and flames. Burning non-plenum rated cables can produce large amounts of smoke, which can quickly fill the air handling space and impede visibility for emergency responders. Melted or burned cables can fall into the air ducts and obstruct airflow, making it difficult for the heating, ventilation, and air conditioning or HVAC system to function properly. For safety, it is essential to use plenum-rated cabling in all air handling spaces, including above ceiling spaces. In more detail, let's discuss the implications of using non-plenum rated cables in air handling spaces and why electrical codes mandate the use of plenum rated cables in these environments. Firstly, understanding the purpose of plenum spaces is critical. Plenums are designated areas within buildings used for air circulation in heating, ventilation, and air conditioning systems. These spaces often exist above suspended ceilings or below raised floors and facilitate the distribution or return of air. Since air handling spaces can distribute smoke and combustion byproducts during a fire, the materials used in these spaces must meet stringent fire safety standards. Secondly, non-plenum rated cables pose a significant fire risk. These cables typically have polyvinyl chloride, or PVC, jackets that release toxic smoke and gases when burned. This smoke can quickly spread through the air handling system, endangering occupants and hindering evacuation efforts. The NEC and other building codes restrict the use of non-plenum rated cables in air handling spaces to mitigate this risk. Now consider the specific requirements outlined in NEC Article 300.22, which addresses wiring methods and materials in ducts, plenums, and other air handling spaces. This article mandates using specific types of cables with adequate fire-resistant characteristics in these areas. These cables are designed to limit flame propagation and smoke production, enhancing safety in the event of a fire. The cables listed in NEC Article 300.22, such as Type MC cable, Type TC cable, mineral insulated metal sheath cable, Type AC cable, Type MI cable, Type ITC non-metallic sheath cable, or other approved cables, have been tested and certified to meet these fire-resistant standards. Let's elaborate on the fire-resistant properties of plenum-rated cables. Plenum-rated cables are constructed with materials that have low smoke and flame characteristics. These cables typically use fluorinated ethylene propylene, or FEP, or other specialized polymers that do not produce significant smoke or toxic fumes when burned. The use of these materials helps to maintain visibility during a fire and reduces the risk of inhalation hazards. Furthermore, plenum-rated cables undergo rigorous testing to ensure they meet the required fire safety standards. These tests include flame spread tests, smoke density tests, and toxicity tests. Cables that pass these tests are certified as plenum rated and can be safely installed in air handling spaces. Also, the installation of non-plenum rated cables in air handling spaces can have legal and insurance implications. Building owners and contractors who violate electrical codes by using non-compliant cables may face fines, legal liabilities, and increased insurance premiums. Insurance companies may deny coverage for fire-related damages if non-compliant materials contributed to the severity of the incident. To ensure compliance with electrical codes and fire safety standards, it is essential to use plenum-rated cables in all air handling spaces. These cables provide enhanced fire resistance, reduced smoke production, and improved safety for building occupants. Electrical inspectors and fire marshals typically verify cable installations to ensure compliance with applicable codes and regulations. To summarize, here are the key reasons why non-plenum rated cable should not be used in air handling spaces. Firstly, fire safety. Non-plenum rated cables pose a fire hazard due to their potential to release toxic smoke and gases when burned. Secondly, code compliance. NEC Article 300.22 mandates using specific types of cables with adequate fire-resistant characteristics in air handling spaces. Thirdly, risk mitigation. Plenum-rated cables mitigate the risk of fire spread, smoke inhalation, and reduced visibility during a fire. Fourthly, legal and insurance implications. Using non-compliant cables can result in fines, legal liabilities, and increased insurance premiums. Lastly, occupant safety. Plenum-rated cables enhance the safety of building occupants by reducing the risk of fire-related injuries and fatalities. Therefore, always use plenum-rated cables in air handling spaces to ensure compliance with electrical codes, fire safety standards, and the safety of building occupants. Now let's delve into the specific types of cables that are permitted for use in plenum spaces as outlined by the National Electrical Code, NEC, and other relevant standards. Understanding the characteristics and applications of these cables will further clarify why non-plenum rated cables are unsuitable for these environments. Firstly, fluorinated ethylene propylene, or FEP cables are common choice for plenum applications. FEP is a thermoplastic fluoropolymer known for its excellent fire resistance, low smoke production, and chemical inertness. FEP cables are suitable for use in air handling spaces due to their ability to withstand high temperatures and resist the spread of flames. These cables are often used for data communication, control circuits, and other low-voltage applications. Secondly, low-smoke polyvinyl chloride, or PVC, cables are another option for plenum spaces, provided they meet specific requirements outlined in the NEC. Low-smoke PVC cables are formulated to produce minimal smoke and toxic fumes when burned, making them safer than standard PVC cables. These cables are typically used in applications where flexibility and cost-effectiveness are important considerations. Thirdly, mineral-insulated metal sheet, or MI, cables are another acceptable option for plenum spaces due to their inherent fire resistance. MI cables consist of copper conductors insulated with a mineral compound, such as magnesium oxide, and enclosed in a metallic sheath. These cables are virtually impervious to fire and can withstand extremely high temperatures, making them ideal for critical circuits and high-temperature environments. Fourthly, optical fiber cables are increasingly used in plenum spaces for data communication and networking applications. Optical fiber cables transmit data using light signals, which are not susceptible to electromagnetic interference or fire hazards. These cables are typically jacketed with plenum-rated materials to ensure compliance with fire safety standards. Also, composite cables that combine different types of conductors such as power, data, and control wires are available with plenum-rated jackets. These cables simplify installations by allowing multiple circuits to be run in a single cable assembly. Composite cables are commonly used in intelligent building systems, audiovisual installations, and other applications where multiple signals need to be transmitted. Furthermore, cable trays and raceways used in plenum spaces must also meet specific fire safety requirements. These support structures should be constructed of non-combustible materials such as steel or aluminum and should be designed to prevent the spread of fire and smoke. Cable ties and fasteners used in plenum spaces should also be plenum rated to ensure that they do not contribute to fire hazards. These accessories should be made of materials that resist melting, dripping, and the release of toxic fumes when exposed to heat. To maintain the integrity of plenum-rated cable installations, proper sealing and fire-stopping methods should be employed. Penetrations through fire-rated walls and floors should be sealed with fire-resistant materials to prevent the spread of fire and smoke. Cable penetration should be tightly sealed to maintain the air handling capabilities of the plenum space. When selecting cables for plenum spaces, it is essential to verify that they are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, or UL, or Intertek, or et al. These testing laboratories evaluate cables to ensure that they meet the applicable fire safety standards and performance requirements. Cables that have been tested and certified by these laboratories are marked with a listing mark or label that indicates their compliance with the relevant standards. To summarize, here are the key types of cables that are permitted for use in plenum spaces. Firstly, fluorinated ethylene propylene, or FEP cables. Secondly, low-smoke polyvinyl chloride, or PVC cables. Thirdly, mineral insulated metal sheet, or MI cables. Fourthly, optical fiber cables. Fifthly, composite cables. These cables offer varying degrees of fire resistance, low smoke production, and other desirable characteristics for plenum applications. By selecting the appropriate type of cable for each application, installers can ensure compliance with electrical codes, fire safety standards, and the safety of building occupants. Now let's explore the potential consequences of using non-plenum rated cables in air handling spaces. Understanding these consequences will further underscore the importance of adhering to electrical codes and fire safety standards. Firstly, fire propagation is a major concern when using non-plenum rated cables in air handling spaces. Non-plenum rated cables typically have polyvinyl chloride, or PVC, jackets that are highly flammable and can quickly spread flames. During a fire, these cables can act as a fuel source, allowing the fire to spread rapidly throughout the building. This can endanger occupants, damage property, and hinder firefighting efforts. Secondly, smoke toxicity is another significant hazard associated with non-plenum rated cables. When burned, PVC cables release toxic smoking gases, including hydrogen chloride, dioxins, and furans. These gases can be harmful or even fatal if inhaled, especially for individuals with respiratory problems. The smoke produced by burning PVC cables can also reduce visibility, making it difficult for occupants to evacuate the building safely. Thirdly, damage to equipment can also result from the use of non-plenum rated cables in air handling spaces. During a fire, the heat and flames can damage or destroy sensitive electronic equipment, such as computers, servers, and communication systems. This can disrupt business operations, cause data loss, and result in costly repairs or replacements. Also, increased insurance premiums can result from the use of non-plenum rated cables in air handling spaces. Insurance companies may charge higher premiums for buildings that do not comply with electrical codes and fire safety standards. In the event of a fire, insurance companies may deny coverage if non-compliant cables contributed to the severity of the incident. Furthermore, legal liabilities can arise from the use of non-plenum rated cables in air handling spaces. Building owners and contractors who violate electrical codes may face lawsuits, fines, and other legal penalties. They may also be held liable for injuries, deaths, and property damage resulting from a fire caused by non-compliant cables. In addition, the integrity of the building's fire protection system can be compromised by the use of non-plenum rated cables. Sprinkler systems, fire alarms, and other fire suppression devices may not function properly if cables melt or burn, obstructing airflow or damaging electrical circuits. This can delay or prevent the activation of fire protection measures, increasing the risk of property damage and loss of life. To mitigate these risks, it is essential to use plenum-rated cables in all air handling spaces. Plenum-rated cables are designed to resist fire propagation, reduce smoke toxicity, and protect equipment from damage. By adhering to electrical codes and fire safety standards, building owners and contractors can minimize the potential consequences of using non-compliant cables. To summarize, here are the key consequences of using non-plenum rated cables in air handling spaces. Firstly, fire propagation. Secondly, smoke toxicity. Thirdly, damage to equipment. Fourthly, increased insurance premiums. Fifthly, legal liabilities. These consequences can have severe impacts on building occupants' property and business operations. Therefore, always use plenum-rated cables in air handling spaces to ensure compliance with electrical codes, fire safety standards, and the safety of building occupants. Let's consider the specific installation practices that should be followed when working with plenum-rated cables. Proper installation techniques are essential to ensure that plenum-rated cables perform as intended and do not compromise the safety of the building. Firstly, cable support is an important aspect of plenum-rated cable installations. Cables should be supported at regular intervals to prevent sagging, strain, and damage. Cable support should be made of non-combustible materials such as metal or plenum-rated plastic and should be securely fastened to the building structure. Secondly, cable routing is another critical consideration. Cable should be routed in a manner that minimizes exposure to heat, moisture, and physical damage. Cable should be kept away from sources of heat, such as lighting fixtures and heating ducts, and should be protected from moisture and corrosive substances. Cable pathways should be clear and unobstructed to allow for easy access and maintenance. Thirdly, cable termination is a key step in plenum-rated cable installations. Cables should be terminated properly to ensure reliable connections and prevent electrical hazards. Connectors and terminations should be compatible with the type of cable being used and should be installed according to the manufacturer's instructions. Cable jackets should be stripped carefully to avoid damaging the conductors, and connections should be tightened securely. Also, cable labeling is important for identifying and tracing cables in plenum spaces. Cables should be labeled clearly and accurately to indicate their function, destination, and any other relevant information. Cable labels should be durable and resistant to fading, smudging, and peeling. Labels should be attached securely to the cables and should be easily visible. Furthermore, cable fire stopping is a crucial aspect of maintaining the integrity of fire-rated walls and floors. Cables that penetrate fire-rated barriers should be sealed with fire-stopping materials to prevent the spread of fire and smoke. Fire-stopping material should be tested and certified to meet the applicable fire safety standards. Cable documentation is essential for maintaining a record of cable installations in plenum spaces. Cable documentation should include information such as cable type, size, length, routing, and termination points. Cable documentation should be stored in a safe and accessible location and should be updated regularly to reflect any changes or modifications to the cable system. To ensure that plenum-rated cables are installed correctly, it is important to use qualified and experienced installers. Installers should be familiar with the applicable electrical codes, fire safety standards, and industry best practices. Installers should have the necessary tools, equipment, and training to perform cable installations safely and effectively. Also, regular inspections and maintenance should be performed to ensure that plenum-rated cables are in good condition and are functioning properly. Inspections should be conducted periodically to identify any signs of damage, wear, or deterioration. Maintenance should be performed as needed to repair or replace any damaged or worn cables or components. To summarize, here are the key installation practices that should be followed when working with plenum-rated cables. Firstly, cable support. Secondly, cable routing. Thirdly, cable termination. Fourthly, cable labeling. Fifthly, cable fire stopping. These practices help to ensure that plenum-rated cables are installed safely, reliably, and in compliance with electrical codes and fire safety standards. By following these practices, building owners and contractors can minimize the risk of fire hazards and protect the safety of building occupants. Now, let's explore some real-world examples and case studies that illustrate the importance of using plenum-rated cables in air handling spaces. These examples will provide practical insights into the potential consequences of using non-compliant cables and the benefits of adhering to electrical codes and fire safety standards. Firstly, consider a case study involving a fire in a commercial office building. The building had non-plenum rated cables installed in the air handling spaces above the suspended ceilings. During a fire, the cables quickly ignited and released toxic smoke and gases, which spread throughout the building via the air handling system. The smoke inhalation caused serious injuries to several occupants, and the building sustained extensive damage. An investigation revealed that the use of non-plenum rated cables contributed to the severity of the fire and the extent of the injuries. Secondly, consider an example of a hospital that had plenum rated cables installed in its air handling spaces. A fire broke out in the hospital due to an electrical malfunction. However, the plenum rated cables did not ignite or release significant amounts of smoke, thanks to the fire-resistant properties of the cables. The fire was contained quickly and the occupants were evacuated safely. The hospital sustained minimal damage and there were no serious injuries. This example demonstrates the effectiveness of plenum-rated cables in preventing the spread of fire and protecting building occupants. Also, consider a scenario in a school where non-plenum rated cables were used in the air handling spaces. During a renovation project, the cables were disturbed and some of the jackets were damaged. As a result, the cables became more susceptible to fire and electrical hazards. The school administration decided to replace all the non-plenum rated cables with plenum rated cables to ensure the safety of the students and staff. This proactive measure helped to prevent potential fire-related incidents and ensured compliance with electrical codes. Furthermore, think about an incident in a data center where plenum-rated cables were used for all the network and power connections. The data center experienced a power surge that caused several electrical components to overheat and catch fire. However, the plenum-rated cables did not contribute to the fire, and the fire suppression system quickly extinguished the flames. The data center was able to resume operations with minimal downtime thanks to the fire-resistant properties of the plenum-rated cables. In addition, think about a manufacturing plant that had non-plenum-rated cables installed in the air handling spaces. During a routine inspection, the cables were found to be in poor condition, with cracked and brittle jackets. The plant management recognized the potential fire hazard and decided to replace all the non-plenum-rated cables with plenum-rated cables. This proactive measure helped to prevent a potential fire and ensured compliance with electrical codes and safety regulations. These real-world examples and case studies demonstrate the critical importance of using plenum-rated cables in air handling spaces. Non-compliant cables can pose significant fire hazards, endanger building occupants, and result in property damage and legal liabilities. By adhering to electrical codes and fire safety standards, building owners and contractors can minimize these risks and ensure the safety of their facilities. To summarize, these examples show firstly the severity of fires with non-plenum cables in commercial buildings, the containment of fires in hospitals with plenum cables, the preventative measures taken in schools, the limited downtime in data centers that use plenum cables, and lastly, the proactive measures taken in manufacturing plants to use plenum cables. These situations showed the effectiveness of using plenum cables and provide real-world implications for all organizations. Therefore, always prioritize the use of plenum-rated cables in air handling spaces to protect lives and property.